microphone. Is this too loud? Can you guys hear okay? Or should I just speak without a microphone? Which is better? Microphone, okay, very well. So we're just going to load up a quick presentation, but I just wanted you guys to first of all, if you have any questions, put your hand up. Like it's such a small group, we should just really be talking to each other. So if you have any Q&A, feel free. We've got 4 of the co-founders here today. So myself, hi, I'm Georgie's son. I'll give you some background on myself. This is Kenta, the CTO. Trung at the back taking a photo for our community channel. 40,000 people wanting to see about this. He's one of our guys, and then also AJ. But what I was going to start with just quickly was, so we're here because tomorrow we're actually going to unveil a demo of our testnet. We're speaking at, it's called, I don't know, do you guys know Global Brain? So we're really fortunate to have one of the youngest partner actually, Taka-san. Where is he? I think he's sitting at the back. Oh, he's hiding behind here. So he was one of our early supporters. So he invested into Perlin on behalf of Global Brain. And we're speaking tomorrow at their annual conference with 850 people, invite only, in Roppongi Hills. So if anything goes wrong or if you've got any feedback on our presentation, please give it to us tonight because we'll amend it before tomorrow. If anything is dreadfully offensive, please tell us.
Yeah, I just want to also ask about something like, how many of you guys are developers? Like, I just give a show of hands, sort of, a little bit. Because I'd really like to know, we're going to be going into sort of a deep dive into really how this new ledger we've made really works. And, in order to do that, like, I can give a very intuitive sense of it, or I can actually go into the mathematics of it, but idealistically,
Yeah, but also, if put your hand up if you're more on the business side. Okay, so alternatively, because I run the business side, we can talk about partnerships, staking. So we've got a bunch of opportunities around how you can also invest and get involved. So maybe, Kenta, if there's only 3 developers, or how many, honestly, put your hands up if you would like to hear, because we also want to have time for everyone to mingle. So if it's too tech heavy, we can also just do a breakout room if you wanted to go into more detail.
I mean, like, it would just be like, what's the amendments we made to the original Satoshi white paper? Because like what we sort of did with the ledger was, what if you, like, for the past decade, ever since the white paper for Bitcoin really came out, there hasn't really been that much progress really that has been made, but really just small little amendments that then made Ethereum, that then made a whole bunch of new kinds of chains. But then, what if we erased all of that history, went back 10 years ago, and tried to look at the Bitcoin paper just a little bit more specifically? So that's the sort of tech talk.
So what we can keep it general, but please feel free to ask questions. This is interactive. We're here for your benefit. So just as background on me, I've co-founded now. We're just gonna set up the overhead. You got it.
Yeah, I'm waiting to set that up.
Okay. Feel free to jump in. So just while we're waiting, as background on me, I've co-founded 20 companies, sold 4 of them. Actually, one of my high school friends that I haven't seen for 12 years is sitting at the back. He's working for Sony Research. Grew up in Sydney, so also been based in Singapore for 8 years. So co-founded now, we've done 3 ICOs, raised about $200 million. Perlin so far has raised $49 million in our private sale, and that's funded us for the next 5 years, which is our goal to just really, what we believe, build the product and get adoption. Also advised now about 12 different cryptocurrencies. So if you're interested in ICOs, where the market is going, stablecoins, my wife and I have invested in about 30 ICOs now. We've co-founded also Virtual Capital, which is it's a crypto fund now managing about $70 million that does Bitcoin arbitrage. So just got a wide sort of like background, but originally 10 years ago, I raised a fund for carbon credits. And then after the disappointment in Paris, and so we ended up raising $400 million to do carbon credits. After the lack of government support, that was when we actually started looking at, alternative, non-government reliant instruments. And that's where we got into Bitcoin. So, and for that work, actually, I think that there's I'll switch this off. So,
Maybe just skip the mic.
yeah. Okay. Yeah, so if you've got any questions about any of that kind of background, please feel free to dive in. Put your... Sorry?
When did you start into blockchain?
So 2014. So 2014 was, I co-founded a company called ChangeCoin, which raised money from blockchain.com, from Blockchain Capital and Pantera. So that was 2014, and it was basically the first Bitcoin tipping bot. And it was actually before Mt. Gox, and so after Mt. Gox, there was some obvious fallout and things kind of, in the end it actually got acqui-hired by Airbnb. Great question though. And then, similarly, what you find is, as the cycles come through, we deployed, so back then I started investing, Bitcoin was $600, and then I thought it was quite high actually. And then it stayed quite flat for a long time, and then it started picking up. So did my first ICO June last year. So that was when the market really started picking up, and there was some really holy shit moments where you just like my wife who used to work with Gucci-san. So Joe, actually, I got her to handle our investment in Power Ledger, and that from when I was an advisor in 3 months went 20x. And that was when she was like, I can never work for Aviva again. So after that, she couldn't work for her insurance company because we started seeing, some really interesting volatility. Today's market, actually, what you're seeing is liquidity, and that volume, the ability to sell, is actually now seeming to be not an advantage, but a disadvantage. So you're seeing a lot of people just dumping out of their positions, which actually you're seeing, I think, an overweighted sell. But what I was going to say as well was, could you put your hand up if you would like translation? Because we also have a translator. Well, not formally, but now that he's worn the shirt, which you gave to him today. Does anyone here put your hand up if you would like to hear Japanese translation?
Korean? Well, if they can only speak English, they won't understand your question. So.
Well, no, just meaning like, we can translate both question and answer. But are there any people here who don't understand, you're right, you're exactly right. Can someone ask if we need Japanese translation?
英語の通訳必要な方いますか?
One, two, 3, 4. Okay. So maybe we can get.
I'll do it on Twitter.
Oh, you're gonna really translate everything on Twitter?
That's okay.
Okay. But if you do want me to speak slower, I'll try to speak slower. But thank you so much for coming. Really appreciate it. So what I'm going to do is I'll walk through quickly the presentation, which we will be sharing tomorrow. But it does seem that it's more of a business crowd. So Kenta, feel free to dive in. But later after, please come grab my business card. We're based in Singapore. You can come by. If you buy some tokens, hey, we'll give you a t-shirt. Don't tell anyone. I can also talk about the fundraising process if people have questions, but let me just give you a quick overview. So what are we doing? Really, if you look at the internet today, it's heavily dominated by a small number of these cloud providers. So if you look at Amazon Web Services, Microsoft Azure, Google Cloud. So because of this, the cost of running websites, the cost of doing compute is very high.
I'll just click it once.
Yeah. What we're doing is we're really creating a decentralized web. And if anyone's seen Silicon Valley, it's quite similar to that, ironically. So today there are 2.4 billion phones, 2 billion laptops, 70 million PlayStations. All of these devices have compute chips. At nighttime when you're sleeping, you can now rent them out. You can rent out the compute, we can aggregate it, and then it effectively will expand the market. So if you think about Uber, before maybe a certain amount of people would catch taxis. Now, with Uber, more people will ride share. And similarly, we think that we can bring the price of compute significantly down and expand the market. But most importantly, I think it's going to be more research, more compute availability, a bigger marketplace. The benefits of a decentralized web is actually, if you think about AWS, they have to rent a warehouse, pay for air conditioning, they have to buy computers, they have to have staff. Let's just look. They have to have staff. I mean, it's a hugely expensive exercise, and we can actually now do this 80% cheaper according to our models. At the back, can you hear me okay?
Perfect.
Good. That's too bad. I kind of like the digital Darth Vader, So it's up to 80% cheaper. And the reason for this, I'll get to it, but it's secure and easy to use. So you would have seen there's been a number of challenges. Oh, thank you. There's been a number of challenges with regards to, whether it's AWS going down, whether it's, compromised security. So this is an idea whose time has come because the encryption that has evolved, as well as the token that has been coming back to the cryptocurrency, we can now create minute transactions based on compute cycles or compute availability. So it's something that's actually only occurred recently. In fact, one of our advisors is a guy called Rob Eldridge, who was for 11 years worked with Jeff Bezos and was the CFO of Amazon Web Services and Amazon for Asia Pacific. So even Amazon Web Services recognizes that the time for a decentralized version of themselves is coming. We've already managed to sign up largely through AJ at the back, but over 377 petaflops of supply. Yes, sir.
377 petaflops. And how large is it compared to AWS?
So the comparison we've used is the largest supercomputer in Singapore is 1 petaflop. The largest supercomputer in the world is about 100 petaflops. So it's 3 times more powerful than the largest supercomputer, but actually there's no public data on how big AWS is. But if you think about Airbnb, Airbnb has more hotel rooms than the biggest hotel chain. And the simple reason is because they don't need to build the hotel. So similarly, when we launch, we're not even launched yet, we expect this to grow far larger than any centralized data center can be. But very good question, but we're just starting. The last one is the social impact. So the reason why we believe we'll be so much cheaper is there are 2 billion people in the world today living on $2 a day. And they all now have smartphones. So if you imagine in the next 5 years, everyone will have smartphones, they'll have connectivity, they'll have power grid, but they'll be poor and they'll be interested to earn this money from these devices or renting out their devices. So that's really the benefits of Perlin. Coming back now, we've actually signed an MOU with Telkomsel. Telkomsel has 183 million phones and 4 million broadband boxes in households across Indonesia. Their belief is that if we're able to offer $200 to $300 a year from people renting out their devices, that's enough to increase their per capita GDP, if you look at Indonesia, by approximately 10 to 15%. That's where they see the sweet spot. And so actually of all of these countries, we've met with government officials. So I've met with the ministers from Myanmar, so we've actually signed with the Indian government. The Indian government has signed with us to run a pilot. We've also launched a hackathon with them. So we really see that particularly where countries are looking for income for their citizens, this is a new way for them to engage income. We've also signed MOUs for usage in terms of research with NUS and MIT. So you can kind of see where the demand is hopefully going to come from research and big companies, and the supply is going to come from developing nations eventually. But initially we've signed with a lot of Ethereum miners who currently are not producing because the cost of Ethereum is so low. but we're pegged to a price which is related to AWS, which is fixed, so it's not reliant on volatile cryptocurrency prices. Any questions at this point? 1, 2, 3. Yes.
So how do you do the calculations? So in comparison to, for example, Golem, how different is your blockchain to this?
So I'll let Kenta answer on the technical side, but just on a financial or business side, Golem specifically is focused on rendering of video. So it's a very specific exercise, whereas what we do is we create a Linux instance on the device so you can run a lot of different operations. So it's the difference. The way I try to describe it is, if Golem is selling you an apple, we're giving you a garden, so you can choose what it is that you want, what operation you want to run. The second big one is Golem does not have privacy preservation, so anything you do is visible. So that's obviously a significant impediment if you're a business. Does that answer your question?
No, it does.
Did you want to add anything to that?
I think I can add some
Okay.
more stuff later on.
Sure.
Yeah.
Second question?
Thank you. How do you make sure the value of the coin will be stable over time?
So the price that demand or the people buying compute will pay will be pegged to AWS. So the token price, we still want it to go up. But actually all it means is you're getting a smaller amount of the token for the same compute if the compute price is stable. So we're not trying to keep the Perl price stable. We want it to go up for investors, but we're saying that we will be pegging to whatever price AWS has, but discounted.
I mean, I can give a bit more on that answer. It's basically because we're essentially doing verifiable computing. We're trying to make a decentralized cloud here. We actually, all the operations, all of the purchases, all of the renting of compute devices, those transactions get recorded on the ledger. Because we have all of these operations logged in a place that everyone has access to, we know the exact amount of supply of compute, we know the exact amount of demand of compute. You know, given the supply and demand, it's then very easy, just basic economics, to then be able to figure out inflation rates, figure out how exactly you should be repegging the value of the price of compute, and essentially turn it into this sort of pegged cryptocurrency. And with pegged cryptocurrency, people can go purchase compute, while simultaneously essentially be trading compute accordingly to the prices with respect to Amazon's cloud prices. So the base rate, which we set compute prices to, is given Amazon's current pricing in the market, times a heavy discount. As the compute usage fluctuates within Perlin as a decentralized cloud, the prices then adjust accordingly. That's pretty much it.
Yep. Next question?
Well, so I have a PlayStation at home. Say I want to make some money with my idle PlayStation. What do I do?
So right now we're releasing the test net. The mainnet is likely to be March to June next year. But for example, we actually, one of the audience members tomorrow, hopefully will be the staff from Sony, and we hope to present to them, because actually PlayStations are only utilized 9% of the day. So if you think about your PlayStation, actually 91% of the time the compute chip sits idle. So when it is live and operational, actually, Kenta, you can answer this. Otherwise I'll be talking all the time.
I mean, basically, you can just imagine the cycles that are unused on your PlayStation can then be rendered into working on tasks for companies.
Right, but I'm more interested in the application process.
Application process, it would be as much as installing an application from the PlayStation Store.
Yeah.
And will the application give you this thing saying, okay, what is my electricity cost? Do I make enough money out of the electricity
Oh,
cost
so
to make it worthwhile selling my computer?
overall, like,
To switch it off.
so overall, like the electricity cost specifically, that would be with respect to, depends which electricity provider you have. But ultimately, the discounts, the sort of profit margins we're abusing here, because Amazon charges a very significant profit margin over the base cost it takes to run compute on these traditional clouds. And the sort of premium we're talking about here is 63x the base cost, easily. So, if I were to be paying $5 to run the servers as AWS, I'm actually charging my customers on behalf of AWS easily $2,000, $4,000, something like that. So take advantage of that margin, and in essence, even with respect to the sort of electricity costs you pay, you as a miner would still easily get a lot of profit.
What I'd add to that as well is I actually think Western countries, like to you, does a few $100s make a difference per year? Not really. So I actually think that there'll be a lot of philanthropic adoption. So, I mean, I'll hand over to Kenta, but we've already run data on cervical cancer screening from Intel, on PlayStations. So, if you have the chance, let's just say you decide to donate your PlayStation compute time, which has a small amount of electricity cost, to cancer research. So I think that there's also going to be with Mercedes-Benz, they're doing energy efficiency around, their production runtimes and how they model their production. Or maybe you can donate it. So one of the people we're talking to is from Oxford, and he's got the most data for the Indian Ocean, looking at climate change impacts on the Indian Ocean. So I actually think, to a Western market, it's more going to come to a philanthropic donation. That being said, I know when I was a kid, I used to earn very little money wearing a bow tie, serving drinks at my local restaurant. I would much rather run all of the devices in my house to earn money. So yeah, very well there could be, but I think my parents would be paying the energy cost. So I think it still makes sense. But yeah, coming back to the actual behavioral economics, I think you're going to see people if you ran SETI at home or folding at home, or BitTorrent, I think that you're going to get different types of emotional drivers, as well as kids whose parents pay for the energy bill, who are yeah man, free tokens. So I think that there's going to be some interesting behavioral economics coming in. But just to answer your question, it's going to be download the app. We're trying to actually integrate with SDKs with some of the more popular apps. So ironically, our head of India just got headhunted to head up Snapchat in India. So the idea that we could if you're not Snapchatting, you might be asleep, and then if you're plugged in, that could trigger a runtime. So there's a few different angles like that. The last thing I'd share as well, because this is a small group and it's being recorded and we'll be posted on the internet, so it's very intimate, so we've met with HTC. HTC, the phone manufacturer, said that if we can have Android and mobile support, early next year, we potentially could also be preloaded onto HTC phones for blockchain. They've got a new Exodus blockchain phone. So there's all of these really interesting new opportunities. And actually we think that Xiaomi, which is the biggest seller of phones in India and a very big seller in Africa, guys like that are going to be really interesting partners. But I'll hand it back over to Kenta. Did you want to talk about the AI stuff?
I think I'm going to start getting into a little bit more on the tech side.
Okay. Yeah. So just I'll finish up.
Okay.
So just really quickly, Kenta will talk about it, but this is a dry run of how the actual platform runs. Not only are we trying to be cheaper, more secure, and have social impact, but we're also trying to actually make it more simple in terms of how you actually operate. So later on, this is some of the UI in terms of if you have an account, you're running AI models. Later on as well, you can see who's doing the work. I'll let Kenta talk to this later, and then also to the wavelet ledger. So currently, my team and I, we have now received we've got token holders token investments from over 180 different strategic investors. So we were led by guys like FBG, Bitmain, Global Brain, Gobi, Danhua, Arrington, Yobi Capital, OK, a whole bunch of them. We've also, it's all on the website as well if you want to see, we've disclosed a lot of our token holders. We've also spoken to the top exchanges. Everything is, we're well known as a project, so everything is really looking at the market macros right now. But what's most interesting, and I'll talk to it quickly, it's not public yet, but we are going to be releasing some really interesting staking opportunities. I'm not too sure. Put your hand up if you know about staking returns and node returns. Yep. Okay. So in essence, if you don't know what staking is, Basically, if you think about people who hold tokens, if you stake, you're effectively creating some type of node which is supporting the infrastructure of the ecosystem. And so rewards will shift from people who hold to people who stake. So I encourage you, if you're holding any staking tokens where you can stake, you should stake your tokens. What we're going to be creating is, if you stake your tokens, create a validator node, you'll be supporting our ledger. So you will receive a percentage of the financial transaction fees. You'll receive a percentage of the smart contract operation fees. You'll also receive a percentage of the compute layer sales. And so that's going to be interesting because that's pegged to USD. So if you imagine that later on, if you want more information, I can provide you with some details, but if you imagine that we're able to achieve our target, which is 0.25% of the cloud market, then you will be receiving, as validator nodes, assuming 100% validation, $8 million of rewards, so 10% on top of that amount. So suddenly you're actually being paid out, and this is similar to almost fixed income. So our legal advisors have shown that we've written a legal opinion that it's not a dividend, it's not like an airdrop. So there's a whole bunch of really interesting ways of returning payout to people who stake. And that's where I think a lot of the demand for investment is going to come. The fourth way is similar to Tezos or EOS. We're going to be paying out a percentage, or 1%, to the validator nodes. So the Perlin token will be one which it will not cost a lot of money. It's not like running a mining operation, but you'll be able to stake the tokens. And most important from this is we really tried to target investors. So for example, Bitmain, F2 Pool, a number of the big mining concerns can provide the supply. And then, people like iAngels, Danhua, Gobi, they've already got portfolios of investee companies where we're able to hopefully generate demand. So we're really trying to bootstrap the marketplace. Last slide really is, this is my email address. My card is at the back. If you have any questions, please come see us. AJ is running product development. Trung is running marketing. So if you've got specific interest, and Kent is the CTO. So I'll hand it over to him. Is there any last questions just on the business side, or yeah?
Can I use GPU to compute?
We actually specifically use proof of stake. So you can actually stake up your GPUs, but really, it doesn't really matter what sort of hardware you use, as long as it's hardware. You're staking it, then you'll get profit.
For computer resource.
Oh, for the compute resource, so the cloud marketplace, definitely yes, you can stake. You can supply out your GPU. Yeah.
Next question.
Okay.
One. Yep.
Real quick on the payouts. Can you decide the timing of your payout for tax reasons?
That's a really good point. We had not actually designed that in, but Trung, can you make a note of that for our spreadsheet? Because when would be optimal for a payout? Just curious. Would it be like April the 15th or?
I'm just saying. Let's say
May.
You have a high tax bill this year, and you wanted to push your payout into next year. Just things like
Interesting. So we had not thought about it, to be honest. Very good point. Interesting. Technically, we could.
Yeah.
Yeah.
It's not like officially built in, but you can actually do it.
But we just thought who in crypto pays taxes? Cut that from the video. I'm just joking. Of course I pay my taxes. Come on. Come on. Gucci-san, Joe, she's got my paying taxes. Okay. Next question at the back.
Yeah. Do you provide any software monitoring system to help you make sure that as you're consuming electricity and selling CPU cycles, you're actually making money?
Specifically, electricity cycles wise, no, but amount of resources you're using, yes. So it really is just exactly how much resources you're using, the memory, the FRES, the CPU, clock frequency, all of that gets monitored literally to as fine of a detail as possible.
But to that point, we do have tokens which we are looking to reward people. So if for example, you wanted to build something for the ecosystem, and all you do is you plug in your whichever region, postcode, whichever electricity provider, what's off peak, on peak. It's not a difficult like widget to build, and we would certainly come talk to us, and we would certainly reward you for building that if you wanted to, because I think it's a very valuable thing to have. Everyone would be looking at it. Yes, sir.
And for your internal use, when you assign compute tasks to different devices, do you analyze what device is executing and doing a mapping of workloads to the capabilities of the device?
Yes.
Because different CPUs and different architectures are...
Right, so there's this sort of matchmaking scheme in which miners get, sort of suppliers get mapped to customer tasks, in this case. It's primarily based on priorities. So depending, as a miner, if you're longer into the system, if you've done much more tasks, you're much more repeatable in this case.
Yeah, but you will have tasks which are very memory intensive, and you have other tasks which are compute intensive, so you might want to choose
So
different hardware for the different tasks, and the price for probably should then be also appropriately.
Right. Sadly, we skipped over the UI, but actually for every single task as a customer you upload to get worked on by suppliers, you can very granularly set how much memory you require, also how much threads, and how much CPU clock frequency at most. So it's very granular in terms of what exactly you need, in comparison to like giving set plans that cloud services typically provide.
I have two questions on the business side, one on the
Okay.
sorry. So there are other companies that are trying to build out collaborative systems for specific for GPUs, only for GPUs, and they don't seem to be doing quite that well because most of the compute seems to be 1070, which has a limit on, let's say, the amount of batch size can I put into it, right? Because I'm assuming this Perlin, if it's going to be purely compute based, it would depend on what sort of the system that architecture is. You can maybe aggregate it, but even aggregating it would be different for me when I'm running my model. If I'm training it, I don't know whether the results that you have shown for your object detection or everything, are they only for inference tasks? And if I'm only doing inference tasks, how would you combine different, let's say, GPUs will have, like, say, 3 gigabytes and 3 gigabytes, how do you combine them together? Give me this.
It's right. So it's not specifically actually combining the capabilities of multiple GPUs together, but rather the reason why you would get multiple instances of different GPUs is because you want to actually redundantly have your model available. So that's on the inference side. If you are a machine learning company and you want to have your model available out, the biggest thing is that you want redundancy in the models, because if a couple of GPUs are busy, you'll always want a couple available so that they can serve your company's customers' tasks.
Depends. I'm talking about the training part, not the inference part. I understand your point about inference. I get that completely. That is a valid point. But only for the training part, I would want to use the entire compute system for a distributed training, for example, right?
Exactly, right. So actually it's very similar then in that case to a lot of the very popular machine learning frameworks, where you actually decide out which parts of your model gets fragmented out to different devices. So PyTorch, for example, what you would do is you would say that you would split all of the devices you have up into shards, and each shard would then execute a very specific set of instructions for your model. Much like that, it's really entirely up to the user, because how you want your model to be split up and then distributed out.
Exactly. The point is exactly that. As a use case, as a user, I would be given, let's say, 3 gigabytes chunk of, let's say, 1070, and then 3 gigabytes of 1080. At that moment, as a researcher, I would not know exactly what size of my model should I put on one part of the network and on the other part. Ideally, in ideal situation, I would want them to be together with the 12 gigabyte of 1070, right? Okay, my point, because you have trained models, so you know that, right?
Right.
So you have an experience with that. So it would the thinking that you're going with that is that as a user, I would take care of if I'm getting different resources from different users. I would assign them different tasks and then maybe even do different batches at the same time.
So are you worried about, like, if you split up your task, will each split have enough memory?
Precisely. So it could be like workloads for you, for example, like for distributed training, if I'm talking about synchronous or asynchronous training, if I have my different worker nodes in different, let's say, in each different compute instance in your case, for example, I would not want that ideally in every case. In some cases, I would want that if I'm doing, like, say, an asynchronous task or all reduced algorithm.
Right. Actually, idealistically, because there are GPUs are very proprietary based, and the kernels on how exactly they're able to handle multiple workloads at once. You want those GPUs prioritized, just work on whatever the shard they're assigned to dictates. So specifically in this case, you actually have very granular information on how much resources each miner has. Because you have that specific amount of resource, a specific amount of information, it's very simple to, in the matchmaking process, per shard, you're going to have the right amount of miners with the right amount of resources, a minimum amount of resources allocated in this case, specifically for your task, for training. Yeah.
One for you,
Yep, sure.
you mentioned about how you raised like 49 million and you are like set for your 5 years. So among those 180, some 100 plus investors, like how do you raise the money? So you mentioned that you can explain something about how did you go about getting all those investors on board, specifically starting with the first one before that would have been the most difficult one. And then what is your like long-term goal for the entire, like what's the kind of confidence that you've given them when they will start getting some of that money back?
Sure. So good question. So first of all, I guess I'll comment on the macro market right now. As you guys would have noticed, the prices and the market cap is down tremendously, 80% plus. So if you look at the coin market cap, it's down 800 billion. So right now is still, you can still raise money. There's still a lot of the guys deploying money, but they're now looking at splits between equity as well as tokens in terms of investment. Often most of them as well are looking for a lead investor. So there are a few lead investors who have made money for other investors in the past. So what we did is we just strategically looked at who are the influencers and the lead investors in the Chinese environment, the Japanese environment, the Korean environment, and the West Coast of America environment. And so we just targeted those guys. Just because I had also previously done a number of other projects and I'd been in the industry. So my advice would be, if you, for example, were keen to do your own project, I'd encourage you to come work with us or work with another well-known project, learn who's who, basically learn the ecosystem. Coming from zero, if you don't have social proof, like a big part of this industry is called social proof. So when we were able to close money from say FBG, then after that, Danhua, Yobi Capital, Link VC, a whole bunch of Chinese money came in. When we closed Arrington Capital and 500 startups and Block Tower, which is Ari Paul, we then got a lot of US money following in. And then when we closed money in Singapore, Signum Capital, there's a few lead investors that really swung. Obviously in Japan, Global Brain is a very influential investor as well. So the just main points would really be, we'd all done time. So we found Kenta because he was, doing his research in AI at Naver, and he had written a whole bunch of blogs on second layer scaling. And so our tech team was like, who's this guy? He's writing some really good stuff. And so we flew to Korea, met with him, we synchronized as a team. So just coming back, it's always team, right timing, macro, and then, if you have a reputation and social proof, and then, the right investors. But right now, so my wife and I, we don't really invest in crypto token projects right now because it's a very uncertain market. Similarly, coming back to your next question, we're probably going to wait. So even though we can list tomorrow on a number of top exchanges, it doesn't make any sense. There's no secondary market. The volumes are down. There's market makers buying up, but it's just costing projects money. So we're most likely going to wait until March, because March to May is when our mainnet will come out. When we come out with the mainnet, we are still in talks with, so some of the big funds still have a lot of money to deploy. That's why I'm flying to San Francisco next week. You guys can check out wdas.world. It's a big conference which is pretty high quality. That's being held, in San Francisco and Singapore twice a year. When I'm over there, the goal is, there's a number of funds that have talked openly about staking. So Polychain is the biggest staker for Tezos, Multicoin, Coin Fund, a whole bunch of these funds are really interested in staking. So I'm going to talk to them and say, if you guys will strategically lock up and be a staker for 1 year, 2 years, that also soaks up some of the circulating supply, reducing the sell pressure. And so we'll probably look at a mainnet listing where people can go straight from having their tokens to staking. The staking will lock up for a year, and then by managing that, we think that we'll probably have circulating supply of around 15% of the tokens, potentially monthly unlocking because of various unlocks, maybe 2% per month. but that's how we would manage a very stable, strong upward trajectory on our token. And so, stuff like that I can talk about in more detail offline. But but just coming back, I hope that answers your question. But the last point I'll make is, so there's going to be regulation coming out in Singapore. There's going to be regulation coming out in a few jurisdictions. I think there's also going to be some upward trajectory pressure because of the halvening. So Bitcoin block rewards will halve in May 2020. So what you've seen historically is starting from 12 months before, so May next year, there's upward pressure because there's going to be a scarcity in Bitcoin. So there's a few of these things. ETFs, will they get approved? There's a few indicators that I think you'll see over the next 12 months. The last point I'll make on that is, I think now is not a bad time to buy. I genuinely do think that if you are interested, what we look at is a small allocation, 1%, 2% of your holdings, depending on what risk profile you have. But I think now actually is an interesting time. I think a lot of projects will die, but I think high quality ones will stick around. No, you're already starting to see scams, people who are running out of money, people who have held, so there'll be also some desperate dumping. But I think, I think
What are the verifiable which you think will survive this?
So there's a bunch. There's
in the major market. So I'm not going to. So if I'm assuming, let's take the top 20% market. Which one do you think those are very strong survivors? Let's say.
So I mean, so for example, obviously, if you look at the top 10, Stellar just gave away 125 million tokens, dollars of tokens, right? So there are some very well funded projects, Stellar, Ripple, Ethereum's not going anywhere. So these ones are really, then the next question is, what's user adoption going to be? Third question is, do their tokenomics actually encourage an upward price pressure? So, like looking at, for example, Perlin with the staking rewards, if you know that money on average has an opportunity cost of 7% return on capital, you can know that if we are successful in hitting our goals in terms of getting people into decentralized cloud, then it will have a baseline yield on your token. So there's ways to look at where is there a price parity to a real world demand that will then create real value. Do you know what I mean? Any other questions? Otherwise, no, thank you. Anything else? Otherwise, I'll hand over to Kenta. Okay?
Any questions?
No, Kenta.
Yeah.
Wait.
Okay, so based on the audience, then in that case, I won't be going too technical. But the biggest thing, so there's a mix of investors, I'm assuming, there's a mix of people who kind of know about the blockchain a little bit. But what I really want to do then is sort of give some groundings, because actually, when I go talk to developers, they're 3 years in, they know about smart contracts, they know about Ethereum, or investors as well. There's a lot of misconceptions about what exactly the blockchain is. So who here has heard about DAGs? Directed acyclic graphs, show of hands. So, they claimed it's this whole new consensus protocol. They claim that, it's this new way of things, it promises utmost scalability. In a sense, that's not really what the point of DAGs are. And actually, a lot of projects try to sell themselves as a DAG in hopes of getting better investment. But I want to show you guys the real cold hard truth, how exactly DAGs work. Actually, what even is a DAG? I want to go all the way back to the basics, even to what a ledger is, because it's very hard to go on pinpoint and see. If all the math you see in research papers nowadays, it's just very hard. All the knowledge is very obfuscated. That it makes the uncertainty is so great. It doesn't make sense. Why would you want to invest? Why would you even want to use a blockchain? So I want to go and show you guys the cool part. Why would you want to use a blockchain? What even is a blockchain? All right. So I'm going to be using the whiteboard a bit, but I want to sort of talk to you guys about even what is a double spending problem. Because it's something that's just sort of very, very difficult to understand, to a lay person. So first, let's talk about double spending. All right.
So say for example, I'm a bank, all right? And what you would do as a bank is you would have the data of everyone's money, everyone's balances, somewhere in some database. So, you know, you can imagine like this is a big database, and then afterwards you'd have all of the data in these small little servers. Why do you have many servers for the database? It's because imagine if the bank's database was unavailable. It all of a sudden got destroyed. So, you know, if this whole thing got destroyed, then that's too bad. The bank's down for a month, for like a day, an hour, a week or something, and the bank loses $100 million. That'd be pretty bad, right? So the standard solution, what you would do as the tech team of the bank is, you know, you would go on and have your database hosted on multiple servers at once. So because, you know, if one of the servers, which has everyone's data, goes down, all of these other servers of everyone's data is alive. And so your bank would still be up and running, even if there's a hardware crash or something like that. Somebody maybe took a hammer and broke your server or something. But okay, so this is like a really nice solution. I'll take the data, I'll take the bank's data, and I'll put it on a bunch of servers. But now here's kind of a big problem, and it's the biggest problem you would probably see in computer science because, you know, Google, Facebook, all of these kind of big companies, they suffer from this problem, and it costs them millions of dollars every single month to even give a partial solution to the problem. Say I'm some person, all right, and in the bank I have $100. I want to go and withdraw $100 from my bank account, okay? And so what I'm going to do is I'm going to talk to one of the servers with the database, one of these servers that know that I have $100. Going to talk to them and I'm going to say, hey, I want $100, okay? And naturally what's going to happen is you got to say, all of this server has to tell the other servers, hey, I withdrew $100. If they didn't tell it to everybody else, then I could just withdraw another $100 from here. So, you know, it'll say that, all right, I have $0 left now. It'll say, withdraw successful. I got $100. But now, this is where the double spending problem happens. It's, what if, you know, I was a little sneaky. I somehow could talk to 2 different databases. They have the same data. I simultaneously at once tell both of them, I want to withdraw $100. They'll both say, okay. Because the first guy I asked to withdraw $100 to couldn't tell all of the other servers in time that I wanted to withdraw $100. Because there's latency, because it takes time for me as a server to talk to other servers out there with the exact same data, there is a sort of miscommunication. I could accidentally, even though I have $100, withdraw $200. Does that kind of make sense to people? Basically, all of a sudden, hey, what the heck, I just cheated the bank, got an extra $100. I can go and make infinite money now and make this bank bankrupt. So that's a double spending problem, all right? And in this double spending problem, what we're trying to do is we're trying to then say, all right, how the hell do we fix it? Simple way, we call it this way in computer science. What if we could achieve a consensus out of all of these servers, even though there's lag, there's latency talking to all these servers. We're trying to tell all these other servers, hey, this guy withdrew $100. How could we still be sure that no matter what kind of trickery I do, I can only withdraw $100? Even if I send 2 requests to withdraw $100, I would never somehow magically get $200 back. All right, this is the double spending problem, but actually this is not even a problem to do with spending. I don't actually even know why it's called double spending. Because, you know, it's not really, oh, sorry, question?
Because technically you're not withdrawing from a bank per se, because you can spend the same money twice.
Right,
And
but
you see goods and services from one person, and then they get nothing when the second spin goes through.
that's true. But then let's consider, so this is the act of replicating changes, replicating the withdrawal of $100, right?
I just want to check real quick. Room check. Does everybody already know this? Do we have to go over, I mean, the business in generals and all that kind of thing?
Oh.
Or is everybody good with this already?
Probably need to explain a little
So I need
bit.
to explain, okay, sorry.
Yeah,
Just
all
checking.
good. Because this generalizes to not more than just me withdrawing money from a bank. Actually, this even happens to, say, there's a MMO, a game, a multiplayer game, and like I'm like a character, I have like a sword or something, and then afterwards, I would level up, something like that, something as simple as that. If I try to record to one server, hey, my character leveled up. If I sent that operation to a bunch of the database servers at once, I might have accidentally leveled up about 30 times. That's the same kind of thing. Because there's inherent latency in replicating data, that's essentially what the problem of double spending is. It's not actually supposed to be called double spending. In computer science, we call it data racing. Because there's inherent latency in trying to replicate data. That essentially is what causes the double spending problem. So, that's basically what the blockchain is trying to solve here. The blockchain is this database. It has a new way of trying to be able to replicate data across a bunch of servers. And that's exactly why it's very interesting, it's so powerful. But it's also very misunderstood. Because one thing is, people claim that blockchains are different from DAGs, for example. So DAGs are directed acyclic graphs. When you think of blockchain, you think about blocks and a chain, right? And that's essentially why it's called blockchain. One common misconception is that a blockchain is a DAG. A blockchain is a directed acyclic graph. What a blockchain actually does as a ledger is that the way they organize these blocks, there's actually a bunch of conflicting histories. This might be one main chain, but there's all of these other conflicting histories connected to each other. And the goal is, if we've got a bunch of conflicting data, what I mean by conflicting, by the way, is if we go back to that example, I try to withdraw $100. The conflict is that I tried to withdraw twice, but I only have $100. Okay? So the conflict then in this case is, hey, in one parallel universe, I withdrew $100 according to this one server. This other server, I also withdrew $100. We got to figure out one right path of history out of all of these conflicting histories. And that essentially is what the blockchain does. What the blockchain does, this is what they typically say, we get the longest chain out of a DAG of conflicting histories, and this longest chain is the truth. It's what really happened in history over time. And that's essentially what defines consensus. So let me go over a much more specific example. Okay. So, all right, imagine this. You have a system, or something like a spreadsheet. This is essentially what the database looks like inside. You have ID, my name, Kenta. I have the balance. I have a bunch of different columns, and it says that I specifically have $100, right? You can imagine that there's this sort of balance. What essentially happens inside a blockchain is the way they represent conflicts. How do we know that
every time I withdraw $100, it's not conflicting with another request to withdraw $100. It's specific because there's this thing called a nonce. And what a nonce is, it's basically this sort of counter. It's a counter which tells us how many transactions we sent out. So if I were to go on and make a transaction, I say that I want to withdraw $100. This is my transaction. There's going to be a nonce which records 0. My nonce would then be incremented to 1. And the next time I make one transaction, my nonce is going to be incremented to 2. The reason why this sort of represents conflict is, imagine I'm going on trying to withdraw $100 from the bank again. If this transaction has a nonce of 0, this has a nonce of 1, then I can safely say that, all right, this transaction is successful, I withdrew $100, but then afterwards the second transaction doesn't make sense. Because there's an order to how these operations happened, and then I would then know that, all right, because there's an order, transaction 0, transaction 1, only the first withdrawal was successful. If I get a transaction with a nonce of 1, then my balance would have been updated to 0, and I wouldn't be able to withdraw anymore. So that's exactly this. But if all of a sudden I had 2 transactions with both with a nonce of 0, that's considered a conflict. Does it kind of make sense, or do you guys have any questions about it? All good? Okay. So then, in that case, I want to explain it. If we know like how conflicts are defined, if we know how the blockchain kind of works, it's all about trying to figure out a path, the ground truth history from a graph of conflicting histories. So the blockchain, it's all about trying to find this one single path that represents the ground truth that everyone accepts. Everyone thinks that this is really what happened, the sequence of operations that happened in the system. What a directed acyclic graph really is then, or these so-called bad consensus protocols, is what if we took this exact same graph, and what if we could actually derive new kinds of heuristics, new kinds of scores or algorithms, not just getting the longest chain anymore, but with all of these conflicting histories, based on them, figure a faster and a safer way to get consensus. So rather than doing the longest chain rule, what if we actually then decided, all right, if there's conflicting history here, conflicting history here, then maybe the ground truth chain was this one. It's all about trying to choose the right history from a graph of conflicting histories. That really is what a ledger is all about. So a ledger, in essence, is 2 things. One is that it's a consensus. It requires a consensus protocol, a way to, out of this graph, figure the ground truth, the real history. Every single node agrees that the history, or the sequence of things that happen inside a bank, is this path. And also 2, this thing called Sybil resistance. So if you have these 2 kinds of components, you can effectively create a safe and secure ledger. Bitcoin, their consensus protocol, it's not proof of work. It's what you call the longest chain rule. And now what Sybil resistance then is Sybil resistance is what you would then call proof of work, proof of stake, all of these other kind of new stuff. And Sybil resistance basically is a way to, if you're given a bunch of computers, how can you trust which one has the most authority, the most power in dictating what are the right transactions in the system? Because you can have a bunch of histories inside a graph, but choosing the right set of histories, it's ultimately dependent on which node has done the most work. You can trust the node of the most work. Sorry, yeah.
2 questions. For the trust part,
Yeah.
I was going to go there. Thanks for mentioning that. The one thing is, as a person who you are work with, let's say, compute, don't think that it's people. That's why they go and invest their money or put their stuff on correctly in some manner, or there is no data leakage or any sort of like change that might happen during the course of my activity.
Oh, so actually, that sort of stuff I'm gonna be getting into a bit later,
Okay.
in terms of the compute stuff.
Second,
Yeah.
let's assume that these are all nodes of pre-compute instances that are just assembled there, and then
Yeah.
any compute function goes and says, I want that question. So you're basically trying to find out which compute is the most important. Something like between a centrality, you're just maybe calculating between a centrality and trying to identify.
Oh, which computer? So in terms of that, that's ultimately stuff to do with the compute layer. Actually, all of this stuff first of all is just about ledgers, about consensus.
So how do
It's
you, what in your Perlin network,
Mhm.
what is the most important thing? So if you're saying that in a very let's say lots of conflicted graphs,
Right.
which is the point that you're taking as?
So we actually implement proof of stake. Right. So there's actually two components. There's a sort of proof of work where you get paid for doing compute work, but there's also one where proof of stake where it governs the ledger in which records all the transactions that happened.
So just really quickly, so pizza has arrived. You know, it's been a long day, and there's some drinks. So what we'll do is, Kenta, you can just, if people are interested in the technical side, it's gonna continue. But also there's also going to be a business breakout if people want to talk more about the business side. But also, just while we've got everyone here, do anyone have any more questions that they might want to address Kenta? Otherwise, are you comfortable doing a breakout with pizza and drinks on the technical, create like a circle or something?
It's all good, yeah.
But any other pressing questions right now? Otherwise, did you want to just do any more quick kind of next steps, and then we can, in the next 5 minutes or whatever, we'll grab pizza and drinks?
Okay. I mean, I guess I can go on and sort of explain the consensus protocol a bit more later. I'll admit that I actually feel like I should explain some of the stuff with the consensus a bit more, more precisely. But actually, you know, I might as well just give a sort of live demo what exactly we've been building, idealistically.
Yeah, and while you set that up,
Yep.
Kenta, so while Kenta sets that up, just to give you context, so the significance of the Avalanche protocol, did you guys put your hand up if you heard about Avalanche before? So it was a really big deal. The guy who published it is a professor from Cornell University.
It's
by an anonymous group of people, but has now been monetized by a professor from Cornell. So Emil Gunsira has just raised money. I think it was at 120 million valuation from a bunch of Silicon Valley guys. The significance of it was Kenta and the team basically have built it. So it's quite significant because I do think it is going to lead to a whole bunch of new projects. One of them will be the Avacoin from Avalanche, but Perlin actually is the first project to build it, and not only build it, harden it, and create a layer on it. So even though like there's a lot of detail in what Kenta is saying, I urge you to just keep an eye on both this project, but also this whole new family of consensus mechanisms. But Kenta, yeah.
Okay. Yeah. I could probably, guess my head's a little woozy, so it's kind of hard for me to talk about the consensus straight. But you know what, like, if you guys are developers, if you are interested in using smart contracts for your company, I just kind of want to show you what our new ledger wavelet can do. Simple as that. So one thing is that we've open sourced our ledger. You can actually go on and use the new ledger we've made right now. You guys can build decentralized applications. You guys can build new kinds of products, new kinds of services, all running on this entirely new ledger we called Wavelet, which is far more scalable than any other blockchain we can see today. Specifically, you can do 10,000 transactions per second. We benchmarked this on Google Cloud with 240 nodes or servers, computers, call it as you may be. And these computers specifically are consumer grade, as in your laptops are capable of being a part of this, supporting this ledger. And as a result, also make a little bit of money if you're interested in becoming a validator. But
Did you say 10,000?
10,000. There's a lot of claims that a lot of projects would claim that they have 50,000 transactions per second, 100,000 transactions per second, 1 million. That doesn't really make sense. Okay, it's actually, if they had 240 supercomputers, I can understand that, because you need a lot of computational power to run a ledger. All right, 10,000 is already kind of hitting it home with consumer grade laptops, and but anyways,
that's a whole nother argument that I'm happy to discuss off the picture. It doesn't make sense if you have more than 20,000, 30,000 transactions per second. But now, in terms of the open source release, Wavelet's released, you guys can start making dApps on it now. And you can actually run your own local testnet on your PCs. It's on GitHub. I can provide you guys some links later. It should be very simple to find out. Search Perlin Wavelet. But say you want to run a 2-node ledger. You've got 2 instances of the ledger. You run with that load. So that's loading one ledger, and then you can go on, run a second ledger. All of a sudden, they're both connected together. And we also provide a web interface, so you can go and test out the ledger all you want. So that essentially is a ledger. Should we get the lights closed?
Yep. Question. Are the contracts written in Go, or is just the compiler, or
Oh, so the ledger's written in Go.
the ledger's written in Go?
Yeah. So smart contracts, we use WebAssembly.
WebAssembly.
So because it's WebAssembly, you can use any of your favorite programming languages, typically systems languages like C++, C, even a variant of TypeScript. And you can basically write smart contracts much more flexibly compared to any other platform right now, like Ethereum, for example. Well, anyways, in terms of how simple it is to really use a ledger, actually, it might be a little small to see right now, so I'll try and increase the font size. Okay. And now, so. Yeah, just doing this so you guys can actually see what's going on in the ledger specifically.
Yeah, as you can see, so when we met Kenta, he's won 17 out of the 20 hackathons he's entered. Stanford and EOS and Google.
So,
that's why.
So these two ledgers, they're now connected to each other. All right, and so one ledger. I locally have a bunch of pearls. Obviously, nobody's going to have this much pearls in the real world. And on the second ledger, I have zero balance. All right. So I have 2 nodes. One node, I personally have a lot of money. The other one, I don't have a lot of money. So we can go and see this. So this is my wallet ID. All right. And so you can see that I have a ton of money on that account. I can go get the ID of the other person, and I can, or actually, I can get the ID of this person and easily just send him money, just like that. So send him 1,000. And I'll then go and record, and you can actually kind of see how exactly the consensus is happening here. I'll probably have to explain how exactly this graph is formed, but every single time I send a transaction, this sort of DAG gets updated, and then we figure patterns inside this DAG to then resolve conflicts. And there you go. I can just go on, send money all willy-nilly. You might be wondering, why is the graph lagging? Actually, that's just because I made the web UI. I didn't have that much time to make the web UI. And websites are kind of slow. In reality, our ledger is actually really, really fast. By how fast? If I press, I made it so if you press enter, it would send a transaction. And that's how fast you can send transactions. All right, it's crazy fast. And what's more is that the website then lags. So sorry, but the web UI is not that good. it will oh yeah, there you go, it updated finally. So the ledger, you guys can run your own local wavelet nodes right now. You can run smart contracts. You can start building apps. You can use Rust, Go, whatever language you're really comfortable with to then make your dApps. That's pretty much it on that side. We use 240 nodes to test all of this. Second part is that we've also been working on the cloud layer. So it's this little addition. We made it so that Wavelet is extensible. You can create plugins and create new features for the Wavelet ledger. The one that we're most interested in is what if you could create a decentralized cloud on this fast ledger? Because you can't create a decentralized cloud if you can't do transactions fast. If I want to buy or rent a server for 10 minutes on a cloud, I don't want to wait 30 minutes for my transaction to go through. Right? This doesn't make sense. So we tried it on the most notorious tasks, the ones that people are the most interested in. How can you run an AI model, distribute it out on a blockchain, a ledger? And the answer is yes, you can. We've developed this new sort of incentivization scheme, this new protocol that lets you have miners or have suppliers of compute trustlessly work on tasks for you. A bit more details into that I'm happy to answer after the presentation. The main gist of it though, you can go on, spawn a bunch of miners. That's simple. I have 5 miner instances directly just running. And I can go on and run an image classification model. And there you go. This is just one single sample image. Given this image of a dog, it can easily classify what exactly is inside this image. And hey, it's a beagle, it's some sort of dog species, and it classified it correctly. You know, if you can get image classification done right on images like just animals, imagine what you could do classifying cervical tumors. Imagine what could happen if all of a sudden you can identify machine failures. The whole point is you can create all kinds of machine learning models. You can write them using the framework we provide, or even comfortably in the ML frameworks, you know, should you do ML, and run them decentralized for extremely cheap prices.
On the inference part. This is
oh yeah.
Only the inference part.
So this is specifically the inference part, right? So training would take a bit more time because I'd have to. The model was trained on ImageNet, so so this model was trained on 7 million images, which takes a lot of computational power. And now we've got 5 whole nodes on this computer, directly running this image classification model. You can do things other than just machine learning. You can even do computational light stuff. You want to host a website, go for it. You want to host up some files, go for it. Really, the sort of use cases you typically have for a cloud, you can do it on Perlin. Yeah.
So you have 5 nodes, right? Which is the part which so each does so you mentioned about sharding. What sharding are you applying on these 5 nodes? Or you're all using one of these?
Using one of these nodes. It's redundantly. Yeah, it's redundant. It's replicated.
Yeah.
Yeah.
So you said you can have storage as well as computing power.
Yes.
You're not going to run into bandwidth problems if you're tapping into cell phones into Zimbabwe?
Right. So specifically, you primarily have to ensure that your node is always well kept alive, and if you don't, then you won't get the incentives.
Right.
Right. So one of the biggest assumptions is actually the customer should have a pretty good internet connection,
Right.
while the miners can actually have a okay internet connection. Because should they disconnect, they might not get reward for doing some compute on one time, but at the other time they'll get their reward.
Charge is small enough.
Yeah. So there's assumptions that you must have a decent internet. Sorry. Yeah.
My question about the scaling. So, what about the CPU power and, for instance, the storage of verifying all these transactions and then storing the whole blockchain? Because I can imagine that if all these transactions are recorded on one block, after a couple of days, these blocks are like a couple of gigabytes. So how are you going to?
So this whole compute layer, the way to do computationally expensive activity, to host websites, all that kind of stuff, the computationally expensive stuff happens off of the chain. But the biggest thing is we need the ledger to be fast, which is why we then went out of our way to build Wavelet. Because if you can't perform fast transactions, how can you have a cloud service? You know, if it takes me 30 minutes to get one server, when I want to serve for 10 minutes, it's gonna just take too long.
So the node won't verify every transaction. That's how that happens off scale.
So we have a completely different scheme on how we verify computation and storage off of the chain. Right. I'm happy to talk about that a bit more after this talk. A little bit of detail. It's a game theoretic incentive-based system. It's a mini-max game. What I mean by mini-max is you've got customers wishing to minimize the amount of money they spend for compute. You've got suppliers wishing to maximize the amount of profit they get doing compute. Because you can wage this as a mini-max game, and you've got the ledger as like a judge. The judge that says, hey, you're doing illegal activity, you're not going to get extra money for that. We can essentially frame this as a game in which we can verify computation, files being kept in storage, for example, all of that kind of nice stuff.
Any other questions?
I was going to ask, how much redundancy is used in the
Redundancy. So
one process is taken to one CPU, or is it spread out and redundant in case one fails?
So it's actually very modular because of this verification framework, how we verify compute and then pay the suppliers for it. You could actually not just redundantly spread out a machine learning model, for example. You can choose to split the work up. It really is up to the customer, and split the workloads into hundreds of thousands of miners at once. So it's very, very modular how you want to define how the work is split up. Of course, this requires a bit of work on the customer's end, but hey, we're giving you a framework and we're giving you the supply of compute. Yeah.
So, if there are more questions, we can break up, but just to kind of summarize why we're in Japan to make it really relevant is we're looking for collaborations, we're looking to build a local community, we're going to be offering rewards and different types of bounties to do different parts of work. So just for example, it's our understanding that there will be changes to which tokens can be listed in Japan next year. So we would like to undertake the process of applying to be one of the listed tokens in Japan. We're also talking to, so for example, as was raised earlier, if you have an idea for a widget that could improve the ecosystem, we're very open to trying to find developers that can build with Kenta and the team. So we're trying to build out a decentralized ecosystem in Japan. So just to summarize as well, on the wavelet level, we are talking to consultants that may want to deploy the wavelet ledger for some of their clients. So if you're interested in that, please come talk to us. On the compute layer, if you have other ideas to build on top of the ledger, on the compute layer as well, if you want to build out models, if you've got AI needs or if you've got compute demand, again, we're looking for partnerships.
No.
Yep.
Just want to add a little bit. So I should also probably demo to you guys how you deploy smart contracts. You literally write this one command after you create your smart contract, press enter, and then you have a smart contract ID. That is your smart contract. It's this long-winded code. And the smart contract we made, just to demo, it's a very simple one. You send the smart contract like 100 pearls, it'll give you back 50 pearls. It just gives you back half the pearls. It's just a small little demo case. So if I go on and send it 100, wrong branch, but it basically should work as is. But to go and show a little bit on how the code looks like, how complicated it is to write a smart contract. A smart contract is just probably like 12 lines of code. This is just a very simple one that goes on and spawns a new smart contract, but just for a little bit of context, it's pretty simple to write smart contracts on Perlin in comparison to learning something like Solidity or Serpent, or there's a bunch of smart contract languages out there. You can use the tools you ordinarily already know, C, C++, anything. Yeah.
Awesome. So thanks so much for showing up. If you've got further questions on either the business or product or technical side, come find us. There's some drinks and food. I think what we're going to do is we're going to move the chairs to the side or start stacking, but thank you so much and really appreciate the time.